Algebra 2, 3-2, solving systems of inequalities by graphing. So last time we solved systems of equations. Now we're solving systems of inequalities. And we're doing that by graphing. All right, so solving, what we're doing when we're talking about solving systems of equations is we are finding all of the ordered pairs that satisfy the inequalities. Don't worry, we're not going to write every single ordered pair down that satisfies the inequalities. We're going to graph it and just shade it in. All right, step one. We've got two steps here. Step one, graph each inequality. Shade the correct area. Step two, identify the common shaded areas. And the common shaded areas, that is the solution. All right, let's see what we're talking about here. Here's an example. I've got y is greater than 2x minus 4, and I've got y is less than or equal to negative 1/2 x plus 3. So let's make a coordinate plane. And let's do 2, 3, 4, 5, 6, 7, 1. Okay, so let's graph this first one. When x is 0 and y is 0, when x is 0, y is negative 4. So I go down to negative 4, 1, 2, 3, 4. And then I use my slope, 2 over 1, so I go up 2 to the right 1. Now, if you don't remember how to graph with the slope-intercept form, just plug in numbers. Do a t-table, plug in a number for x, find what y is, do that a few times, and then you get a line. So up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Okay, there's my line. Now I'm going to just lightly do this line. Because it's an inequality, I have to decide if this should be a solid line where the solution is included, where the line is included in the solution, or if it's a dotted line where the line is not included. Since this is not or equals to, then I need a dotted line because the line is not included in the solution. So I get a dotted line there. Now, I'm going to graph this line, up 3, 1, 2, 3, and negative 1 over 2 is my slope, so negative 1 and 2, I can go down 2 to the right, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, and so on and so forth. So I'm going to, that looks like 1, 2, 1, 2, okay. So now this one is or equals to, I'm just going to draw my line lightly first though. And then I'm going to think, oh, or equals to. So that means this is a solid line. My line is included in my solution. Now, what I haven't done yet is shaded the correct area. So I'm going to look at this first one, which is this dotted guy, and I'm going to decide where to shade. Its y is greater than this line, so I'm going to shade above it. Now, if I wasn't sure where to shade, I could just choose this point, 0, 0, and see if it makes sense. If I plug 0 in for x, and I plug 0 in for y, I get 0 is greater than -4, because 0 times 2 is 0, so I just end up with -4. Is 0 greater than -4? Yes, it is. So that's the part that I would shade. If it wasn't, if this was incorrect, then I would shade on the opposite side. Now for this one, y is less than my graph here, my line, so I'm going to shade underneath y is less than. So I've done my shading. Now I'm going to look at the common areas. So here, this area is where I have the common shaded area. So I am going to give that one a little bit more strength in my shading, and that way I can very easily see this is the solution for these inequalities, for this system of inequalities. Let's do another one. This would be a we try if we were here together. Y is less than or equal to the absolute value of x, and y is less than 4/3 x plus 5. So I would have you guys, if we were here together, talk to me about how we would make this graph together. So if you want to try to give this a try without me, go ahead and do it and pause right now and get to work. If not, let's do this together. The absolute value of x looks something like this, right? 45-degree angle. There's the absolute value of x. It's or equals to, so this is a solid line. And then y is greater than or equal to, so I'm going to shade that in. Now, so that's been graphed. Now let's graph this other one. Y is less than 4/3x plus 5. So I'm going to go up 5. And there is my y-intercept. And then 4/3 means I go up 3 to the up 4 to the right 3, or I go down 4 to the left 3. Either one. So I'm going to go down 4 to the left 3 because this is where I am on my graph. 1, 2, 3, 4 to the left. 1, 2, 3. There we go. And then 1, 2, 3, 4 to the left. 1, 2, 3. Oh, that's bad. All right, there we go. And this is going to be a dotted line, so I might kind of do a light line here so I can see what's happening, and then make a dotted line. And y is less than this line, so I'm going to shade underneath. Then step 2, I'm going to identify the areas of overlap, and that's right there. And I have graphed my system of equations. Let's do one more. This one definitely I'd like you to try on your own. Y is greater than or equal, less than or equal to -2x plus 5, and y is greater than, goodness, why am I doing this backwards? Y is greater than -1/4 x minus 6. Okay, so go ahead and pause and do this work. Go. All right, now I am going to do this. Let's see how you guys did. Let's check your work with mine. So I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So this top one here this top inequality, I'm going to go up 5. 1, 2, 3, 4, 5. There's my y-intercept. Negative 2 is my slope. So I go down 2 to the right 1. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. All right. So this is or equals to, so I know I'm going to have a solid line here. And then I'm going to, y is less than, so I'm going to shade underneath, just lightly. Now, I'm going to do this line, and I go to negative 6. 1, 2, 3, 4, 5, 6. There's my y-intercept. And then this one, my slope is negative 1 over 4. So I'd be down 1 to the right 4. I'm already pretty low here, so I'm going to go up 1 and back 4. So notice I'm doing the opposite of both of them, and I should end up with the same line. So I go up 1 and then over to the left 4. 1, 2, 3, 4. There's my point. Up 1 to the left 4. 1, 2, 3, 4. And this is or equals to, so my line is going to be dotted. I mean, not or equals to, which is why my line is going to be dotted. This line is not included in the solution. Okay, and y is greater than, so that means I'm going to shade above like this. And I'm going to notice that the overlap is right here in between these two guys. And so there is my solution. And this solution goes on in this direction forever. So as I talked about how we weren't going to list all of the all of the ordered pairs, part of the reason for that is because there is an infinite number of ordered pairs involved in this solution. Actually, in all of these solutions, there's an infinite number of ordered pairs. So we're not going to list those. That would take way too long. Now, let's look at some more systems of equations. We're going to look at separate regions. And so let's see an example of what this might look like. Y is greater than or equal to x plus 5, and y is less than x minus 4. Let's see what this looks like. Let's go up like 6 or so. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There we go. All right, let's do this top one first. X plus 5. So 5 is my y-intercept. 1, 2, 3, 4, 5. Plot that point. And then my slope is 1 over 1. So I can go up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1, down 1 to the left 1. There is my my line, and it is or equals to, so my line is included in the solution set. Now this one is, oh, and let's also, y is greater than or equal to, so that means we shade above. Now let's look at this line, and this one is, the y-intercept is at negative 4, 1, 2, 3, 4. And my slope is the same, up 1 to the right 1, up 1 to the right 1, down 1 to the left 1, whatever. So it's at, so the slopes are the same, and this one is not or equals to, so it is a dotted line. Now I didn't draw this perfectly, but since I know the slopes are the same, that means these two lines are parallel. So they will never cross. Y is less than this one. So we know, so now when I look at this, since the shaded regions are going off the wrong direction, or opposite directions from one another, they don't cross ever anywhere. So that means we have an empty set. or we might say no solution. But empty set is a term that we can use to talk about what happened here. Up here on these other ones, we've got shaded here, and they mix together, so they overlap. In this empty set, they do not overlap ever, anywhere, and therefore it's an empty set, because the shaded regions do not overlap. All right, now we're going to move on to something a little bit different here, and this is, we are going to find some vertices. So when we have a system of equations that is, we'll say, our 3 lines. So let's think about if we've got 3 lines, we're going to draw 3 coordinate planes. And we could draw 4, but let's, there could be more than just this. So if we have 3 lines, they could, let's make some notches here so we know these are the coordinate planes. All right, so if I have 3 lines, I could have one that goes like this, I could have one that goes like this, and I could have one that goes like this, right? So we can have 3 points of intersection here. We could also have 2 that are perpendicular and one that goes like right through them both, and then I would only have 2 points of intersection. I could have 3 lines that were parallel, and so none of them would intersect ever. We could also have 2 lines that are on top of each other and one that goes through like that, so we would just have 1 point of intersection. So there's a variety. When we're looking for vertices, that's where the lines are crossing one another. You might just have one, you might have a bunch, so we're going to go through and see how we might find this out. Here's an example. When we're looking for vertices, I've got 2x minus y is greater than or equal to -1. I've got x plus y is greater than 4. And I've got x plus 4y is less than or equal to 4. All right, all of these are less than or greater than or equal to. What I need to do here in order to graph this, because I'm going to graph these to help me know how many vertices I'm going to be looking for. But before I do that, I've got to change this to slope-intercept form to make it a little bit easier for me. You could also just find the points of the y-intercept and the x-intercept if you wanted to graph it that way. You could totally do it that way. Or you could change this to slope-intercept form. So for this one, I'm going to change this one to slope-intercept form by subtracting 2x from each side and then multiplying by -1. So if I subtract 2x from each side, I've got -y is less than or equal to -2x minus 1. Now I need to multiply this whole thing by -1, and when I do that, I need to switch my sign. So if I multiply everything by -1, I need to say y is less than or equal to 2x plus 1. All right, so that's that one. For this one, I'm just going to subtract x from both sides and I'm all set. Y is less than or equal to -x plus 4. So that's that one. This one is here. This one is here. For this one, I'm going to subtract x from both sides and divide by 4. So I've got y is greater than or equal to 1/4 x, -1/4 x, because I subtracted x from both sides. And then 4 divided by 4 is 1 plus 1. Sorry, I kind of just skipped a step. I want to keep moving. All right, now let's graph these and see where they intersect, how many points we're going to try to find. Let's do that. Oh, let's do that together. Okay, let's graph this first one here. plus 1 is going to be my y-intercept, and then I'm going to go up 2 to the right 1, 1, 2 to the right 1, 1, 2 to the right 1. There is this line. It looks like this. And I'm going to shade below it. It's what it equals to, so it's a solid line. All right, now I'm going to graph this one. I go up 4, 1, 2, 3, 4. And my slope is -1 over 1, so I'm going to go down 1 to the right 1. There's a point of intersection possibly right there if I did my graph well enough. Down 1 to the right 1, down 1 to the right 1. All right, so this is like this. And I see there is at least there's one point of intersection here between these two lines. Let's see what this one looks like. Plus 1, and then down 1 to the right 4. 1, 2, 3, 4. And then down 1 to the right 4 again, over and over again. I didn't shade here on that last one, or the second to last one, and then the last one I'm shading y is above. So this little triangle in here is where all of the lines, the regions of solution are all overlap in this little triangle in here. All right, now I need to find these 3 points of intersection. Here's how I do it. I take this one and this one. I say 2x minus y is, I'm just going to put equals because the inequality signs don't matter when I'm just trying to find these points of intersection. And I'm going to say x plus y equals 4. So I just transferred these down here. I'm going to use elimination because I've got -y and +y, so those just go away. And I end up with 2x plus 1x, which is 3x equals 3. -3 and 4 is 3. Divide by 3. X equals 1. So I have a point that is 1, and now I need to find this other, the y value. So I plug this 1 back into any of these equations. I'm going to plug it into this one. So I'm going to say 1 plus y equals 4. Subtract 1, y equals 3. So one of my points of intersection is 1, 3. That looks like this one right here. 1, 3. Now I need 2 more points of intersection. So now I'm going to look at this, this line and this line. X plus y equals 4 and x plus 4y equals 4. And I'm just going to multiply this whole top by -1. So I end up with -x minus y equals -4. Negative x plus positive x is 0. Negative 1y plus 4y is 3y equals -4, +4 is going to get me 0. So if I divide both sides by 3, y equals 0. So for this point, I've got, I don't know what my x value is yet, but I know my y value is 0. So now I plug y equals 0 into one of these. I'm going to plug it into this one. So x plus 0 equals 4, x equals 4. And that would be this one here, 1, 2, 3, 4, 0. Now you can see how I didn't do an awesome job on my graph. This point ended up being like between 3 and 4. So you can't always rely on your graph unless you do a really, really good job on your graph. So 1, 3, 4, 0. Now let's look at the next one, which I'm going to have to do the first and the third. So 2x minus y equals -1, and x plus 4y equals 4. I'm going to multiply the bottom by -2. And I'm just going to rewrite the whole thing just to make it a little bit easier. So 2x minus y equals -1. -2 times x is -2x minus 8y. equals negative 8. Now I'm going to eliminate what I'm going to eliminate. The x's go away. I've got negative 9y equals negative 9. Divide both sides by negative 9. Y equals positive 1. So my point for this one is going to be 1. My y value is going to be 1. I need to find my x value. I'm going to plug 1 into this equation here. So I've got 2x minus 1 equals negative 1. So I'm going to add 1 to both sides, plus 1, 2x equals 0, divide by 2, x equals 0, 0, 1. That's right here, 0, 1. And those are my 3 points of intersection, or my vertices. Let's have you do one to get on your own. You try. 5y is less than or equal to 2x plus 9. Y is less than or equal to negative x plus 6. And 9y is greater than or equal to negative 2x plus 5. All right, so I'm going to have you work on this one on your own. Now, this one is going to be fairly tough to graph because you're not going to have a clean y-intercept. So it's okay to not graph these. If you want to just go straight into this kind of work to find your vertices, because that's all you're being asked to do is find the vertices. So you can go ahead and do that and see what you get. See if you're going to get 3 vertices or how many you end up with. So go ahead and pause and do this work. This is the last thing we're doing for this section. Go. All right. I'm going to do these two first. So I've got 5y equals 2x plus 9 and y equals negative x plus 6. I'm going to write down all of the equations I'm going to do just off the bat. So I'm going to say y equals negative x plus 6 and 9y equals negative 2x plus 5. And then the last one are the top and the bottom. So 5y equals 2x plus 9 over 9y equals negative 2x plus 5. Okay, I just wanted to write them all out and have them there. For this one, now I can use substitution because I have y equals already. So we haven't done any substitution for a while, so I'm going to just use substitution. Y equals this. So I'm going to say 5 times negative x plus 6 equals 2x plus 9. So I've taken this and I've plugged it in there for y. So negative 5x plus 30 equals 2x plus 9. I'm going to add 5x to both sides. And since we are in Algebra 2, I can do kind of 2 steps at one time. Subtract 9 from each side. Those go away, those go away. I've got 21 equals 7x, divide by 7, and x equals 3. So for this one, the vertice, the point of intersection between these two lines is 3 something. I don't know what my y value is. I'm going to plug it in here. Negative 3 plus 6 is positive 3. So that means 3 is my point of intersection between those two. I'm going to do the substitution again for this one because that's fun. So I'm going to take this value and plug it in for y. 9 times negative x plus 6 equals negative 2x plus 5. Distribute my 9 here, so negative 9x plus 9 times 6 is 54 equals negative 2x plus 5. I'm going to add 9x to both sides, and I'm going to subtract 5 from both sides. So that goes away there, and I have 49 equals negative 2